Today we will study characteristics of the magnetic force. Number 1. Where is magnetic force applied? Answer: in a magnetic field. On what a magnetic force is applied? Who experiences the magnetic force? Answer: a moving charge. So, here is certain magnetic field, and magnetic field we will show here in a particular direction, say going inside, that is in Z axis, and we will show it this way. Here we place a conductor in which charge is moving. Say this is the conductor. In this current I is flowing in it, so the charges are moving. If the charges are moving in this direction, then it will experience a force. And what will be the direction of that force? Answer: direction of that force will be given by the Ampere's left hand rule, that magnetic field is inside, this is the direction of current, so this is the force. The force here will act in a direction perpendicular to current. So if when charge is here, the force is acting in this direction. This is force F acting perpendicular to it. Now what happens because of this force? We know that a force can do the three things: increase the velocity, decrease the velocity, or can change the direction. For increasing or decreasing the velocity, it should be acting in the direction of velocity, or its component should be acting in direction of velocity. Here this is the force. What is the component of this force in this direction? Answer is F cos 90, and F cos 90 is 0. So no force is acting in this direction. If no force is acting in the direction of velocity, then this force cannot change the magnitude of velocity. It cannot increase, it cannot decrease the velocity. So I will write the same thing: magnetic force. Magnetic force cannot change the magnitude of velocity. That means speed. It cannot change the speed. And you know because its component along V is 0. Okay, then what is the effect of this force? Effect of this force is that its direction will change. Here is a particle moving like this, and we apply a force this way. It will move like this. If we apply a force this way, it will move like this. What is happening? The direction keeps on changing. So here what will happen? It can change the direction. So these are the two things a magnetic force is doing: no change in magnitude of speed, and it can change direction. If this direction is changing and this becomes like this, then the force is always at right angle to velocity, and in this case the force will automatically, see, if this was velocity, this was force. If velocity has become like this, the force will also become like this. If velocity has become like this, the force will become in this direction. So force is always at right angle to velocity here. Now if velocity has, because the charge is going here, there is a force here, it will turn and become like this. Then force will be at right angle to this. If it turns like this, because of this force, it will bend like this, turn like this, and then velocity, the force will always be at right angle. In this way we find velocity will turn, and again go here. And force is always at right angle to velocity, always. So the force is also changing its direction. Here the force is here. Here the force is here. Here, here. So this is magnetic force. The direction of B is constant. That is there. Now, what happens in electric field? This what we have seen. Watch, magnetic field. Now, the electric field is there. If there is an electric field in this particular direction, electric field, and there is a charge in it, this charge experiences a force, and the direction of that force is the direction of electric field, this. Now, if a particle is here, it experiences a force in the direction of electric field. That force gives its acceleration, and because of the acceleration, velocity increase. Velocity increase. That is magnitude of velocity, that is speed increase. What happens to its direction? The answer is direction do not change. It keeps on moving in the direction of E. If you say the charge was going in this direction, if the charge is moving in this direction and there is an electric field in this direction, then what will happen? The answer is because of this force. Which force? QE. It will bend like this. And after that, it will keep moving in this direction, and you find here the direction do not change. It is turning. Is it turning? Answer no. It is going in the direction of E. So, electric field fail to change the direction. It always carries electric charge in the direction of electric field. It does not change the direction. Here, because this direction was not in the field, it has changed the direction to electric field. But it will not change the direction from here. So, it cannot change direction. It carries in one direction only. No change in direction. So, these are two contradictory things, and you must remember this. Cannot change velocity. Cannot change velocity. Velocity increase or decrease. This. Then it can change direction. It can. I can write it. It does change. It keeps on changing direction. It makes the direction constant. This is the difference between the two, and you must remember these two differences. One, speed can be increased only by electric field. Magnetic field cannot increase the speed, cannot decrease the speed. Remember it. One thumb rule. Second thumb rule. Magnetic field, what it can do? It can always change the direction of the motion, and it tries to make it a circular motion. Always. While electric field always tries to make its unidirectional, the charge will move on, moving the direction of electric field. This is the difference of electric field application and magnetic field application. So, this is magnetic field application on charge. Both will be acting on charge. This is electric field application on charge. And one thing, very important thing, that was initial. This will act only and only if, yes, if this is there. What is this? V. Here, this will act and it does not need any velocity. So, that is our rule number. Actually, that should be rule number 1. What that? Needs charge to move. Yes. And here act on stationary as well as moving charge. So this will act on both stationary charge and moving charge. This will act only on the moving charge. This is again a difference. So these are the three differences. You will remember: force due to magnetic field and force due to electric field. Both are forces on the charge. This is force on stationary, moving, both. This is force only on the moving charges. Okay, and after this, in the next lecture, we will study what is the Lorentz forces.